Alright, so our first lesson of Chapter 5 is going to be on perpendicular bisectors and angle bisectors. So, two new definitions, but they use vocabulary we've already talked about before. So the first vocabulary term we're going to talk about is a perpendicular bisector. So I'm going to describe the perpendicular bisector theorem and then some of the properties of a perpendicular bisector. So the perpendicular bisector theorem states that in a plane, if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So, to describe this theorem, it says if CP is this perpendicular bisector of the segment AB, then CA is equal to CB, meaning C is equidistant from A and B. So C is the same distance from A and B. No matter where C is on this perpendicular bisector, it is the same distance from A as it is from B, meaning that segment CA and segment CB are congruent. Okay? The converse of the perpendicular bisector theorem, that states that in a plane, if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector of the segment. Meaning, if DA is equal to DB, then point D lies on the perpendicular bisector of AB. The perpendicular bisector of AB is this line, CP. We can assume that D lies on that perpendicular bisector because it is the same distance from A as it is from B. So in example 1, we're going to use the perpendicular bisector theorem to find some measures. So from what we just talked about, we're finding the measure of RS, or the length of RS. Our perpendicular bisector theorem tells us that if S is on the perpendicular bisector, that SP and SR are congruent, meaning RS has to be 6.8. Okay, has to be 6.8. Because SQ is a perpendicular bisector. The reason I know SQ is a perpendicular bisector is that the definition of perpendicular tells us that it creates a right angle with RP. The fact that it's a bisector means that it cuts RP in half into two congruent segments. Okay. So in the next example, EG, we are finding the length of this entire segment. Now, since H is the same distance from G as it is from E, and this line, FH, creates a perpendicular to the segment EG, we can say that EG is being bisected, meaning that EF also equals 9.5. Using that knowledge, 9.5 times 2, or 9.5 plus 9.5, is 19. So EG is 19 units long. And then the last example is very similar to part A. D is on the perpendicular bisector of CA. So CD and AD are congruent. So I can set up the equation where 5x is equal to 3x plus 14. Solving that, I can subtract 3x from both sides. So 2x is 14. X is 7. Now that doesn't answer the question that was asked initially. The question was, what is the length of AD, or the measure of AD? The measure of AD would require me to take 7 and substitute it in for x to this expression 5x. So 5 times 7 ends up being 35. So AD is 35. Moving ahead, I want you to work through this guided practice. And when you're ready, resume the video, check over the answers, correct your mistakes, and then we'll move on to the back side of the notes. Okay, so just to quickly explain, number 1, ZX is the perpendicular bisector of WY, so that makes YZ and WZ congruent. So it's just matching up those segments. WZ is just 13.75. And number 2, if ZX is the perpendicular bisector, that means that WZ and YZ are congruent again. So I can set those expressions equal to each other. I solved. I got N is 10. I substitute 10 into the expression for YZ. I get YZ is 27. And then finally in number 3, it says find WX when WZ is 20.5, YZ is 20.5, and WY is 14.8. WY is the segment being bisected, meaning that segment is being cut into 2 congruent parts. So I would take the measure of WY and divide it by 2 to get the measure of WX, which is 7.4. So moving to the backside, we're going to cover one more definition and one more theorem, and that is something called the angle bisector theorem. And it's a pretty straightforward theorem, all right? It describes an angle bisector. It's right in the name. So it states that if a point lies on the bisector of an angle, so usually a ray, cutting an angle into 2 congruent parts, then it is equidistant from the 2 sides of the angle. So the point that lies on this perpendicular bisector is D. It is equal distance from AB as it is from AC. The main thing I want you to get from this is that the shortest distance between a point and a line or a ray or a segment is a perpendicular. The shortest distance between D right here, I'll use a different color. The shortest distance between D and AB is a straight shot perpendicular. So these segments DB and DC are congruent when we have an angle bisector, right? The converse of that states that if a point is in the interior of an angle and is equidistant from the 2 sides of the angle, then it lies on the bisector of the angle. So it says if D is the same distance from this side as it is from this side, then that means AD bisects BAC, meaning that this angle BAD and this angle CAD are congruent. That angle is being bisected. So for example 3, we're going to use the angle bisector theorem to find some measures. We're going to find the measure of GFJ. GFJ is this part of the angle right here. Okay. So from this, point J is the same distance from this side as it is from this side. So that means I'll do FJ. Ray FJ is an angle bisector. So that means that the measure of angle GFJ is also 42 because this angle is being split into 2 congruent parts. Okay. Now in part B, I want to find the measure of RS. Now we're given that this QS is an angle bisector. So ray QS is an angle bisector. What that allows us to say is that SP and SR are the same length, so I can set up this equation, 6x minus 5 equals, 6x minus 5, not 5x. 6x minus 5 equals 5x. So to solve this, I would subtract 6x from both sides, leaving me with negative 5 equals negative x, making x equal to 5. Now that doesn't give me the answer, but it helps me find the answer. RS or SR, I would substitute x, or 5 in for x. So that would be 6 times 5, which is 30. 30 minus 5 is 25. So RS is 25. So it's being able to know what you can assume is congruent to what in a diagram. So the last example, in my opinion, the most complex example, is writing an equation for a bisector. So this is most likely a level 4 question on a quiz. So writing an equation. Now, the hint I'm going to give you to write this equation, we're going to write the equation in slope-intercept form. So you have to remember that M means slope, B means the y-intercept. So in an example like this, the very first thing I'm going to do is I'm going to graph the 2 points of the segment, the 2 endpoints of the segment. -2, +3 is point P, 4, 1 is point Q. So to find this perpendicular bisector, I need to find 2 things. I need to find the midpoint, and I need to find the perpendicular slope of this segment. So it would help to draw a somewhat straight line or straight segment connecting P and Q. So to find where that bisector hits our segment, we've got to find the midpoint. So when looking at this, you can kind of not estimate, but I want you to be able to find the midpoint legitimately. The midpoint of this segment is right here at the point 1, 2, right? Splits that segment into 2 congruent parts. Now, the part that I want to focus on right now, I'm going to do in red. And I'm going to put a little box here to help. The slope of PQ. We talk about slope, it's about counting rise over run. To get the rise over run of PQ, I would go down 2 and right 6, giving this a slope of -2/6, which is really a slope of -1/3. I go down 2, right 6, okay? That's how we get a slope of -2/6, which is -1/3. The perpendicular slope. It's remembering from before, the perpendicular slope to -1/3 is +3/1, or just +3, either way. So for our equation to the left here, the slope is going to be 3. The hard part is finding the y-intercept now. So what I'm going to do is I'm going to draw the slope from this blue point, from this midpoint, going up 1, 2, 3, right 1, and going down the opposite way, 1, 2, 3, left 1. And then I draw my line. And what that reveals to us is that our y-intercept is -1. So my equation in the end, I'm going to do this in yellow, kind of big, y equals 3x minus 1. So I know I threw a lot at you on that last example, but you've got to be able to find some of these things when you're determining the definition of a perpendicular bisector. So you're going to have some practice on this. We're going to come back to this later on, talk about slope and those types of things. So you're probably ready for the practice. I know this video went longer than usual, but this last example did consume some of the time reviewing some things that we've talked about in previous chapters.